Okay, in this video, we're going to talk about finding the domain of a variable. So what the domain of a variable is, and you may have heard like find the domain of this function or something. It's a similar situation, except now we aren't just talking about functions. We're just talking about any variable. The set of values that a variable may assume is called the domain of the variable. So it's any values, or it's a list of all the values that that variable can be. Okay. We're going to learn some steps to finding it, and then we're going to go through a few examples. So these are the methods that we'll use to find the domain of a variable. First, we're going to assume that it can be whatever it wants. It can be any real number from negative infinity to positive infinity. So it can be all real numbers. And that's what we're talking about here. Next, we're going to look if the variable is in the denominator. Okay, if the variable is below the fraction bar, then what we need to do is remove any values that will make that denominator 0, because dividing by 0 is not defined. And so we need to remove any values that will cause that. And then the next thing we need to do is see if the variable is under an even root. And what I mean by that is a square root. We got x under a square root, fourth root, x under there, or if there's like some algebraic expression of x. Let's say it's a sixth root, and we have x plus 2 under that root. So it'd be all these situations. If you have a cube root of some expression of the variable, so let's say the cube root of x minus 3, then we don't need to worry about it because it's an odd root that we're looking at. But if it's an even root, then we need to make sure that whatever the expression is under that root has to be greater than 0. Okay, so let's go ahead. Let's look at some examples here. And there we go. All right, so let's say that we want to find the domain of x for these expressions that we're going to look at. So the first one that we're going to look at is going to be 5 over x minus 2. So we're going to look at the stuff that we just talked about and determine what the domain of the variable x in this case is going to be. So first, we're going to assume it could be negative infinity to positive infinity. That's what we're going to do first. We're going to assume it's negative infinity to positive infinity. That's the first step of our process. The next step is the variable x in this case in the denominator? Is it below the fraction bar? Yeah, well, we got this x right here. That's below fraction bar. It's in the denominator. So we need to take this whole denominator, the x minus 2, and we need to see are there any values for x that will make that equal to 0. So the way that I do that is, since we want to eliminate those values, I set it the x minus 2 not equal to 0. Let me clean that up a little bit. There we go. And then we're going to solve this. Basically, it's an equation, but we're saying we're figuring out what it can't be. So to do that, we'll add 2 to both sides. And we'll get x cannot equal 2. And so this is a limitation for our domain of that variable x. X cannot be 2. Now we're not done. We need to look at the third step. Remember, the third step was, is there a variable under an even root? There's no roots here, and so we don't have to worry about that. So the only domain restriction we have is that x cannot be 2. Now, there's a few different ways to express this. We can simply, kind of the easy method to say it is just x cannot be 2, so it can be anything else. There's a few ways to write that we'll see. There's one called set builder notation, which will be where you'll have a brace. It'll say x where x cannot equal 2. And so that vertical bar here, that means where or such that. And so you're saying that it could be any x such that x is not equal to 2. Okay, that's one way to write it. Another way to write it is in interval notation. And when we think about that, I always think it's best to talk about a number line, kind of like what I talked about in the previous section we're looking at. Try to make a good number line. There we go, it's decent enough. And so how do we depict this on a number line? Well, let's put 0 here, let's put 1, let's put 2, let's put 3, put 4, -1, -2, and -3. Okay, so if we're saying it's everything but 2, that means it is everything to the left of 2. So it'll be everything here. It's everything to the right of 2, everything here. So it's everything but 2. Let's get a little bit better color on here. Let's go with green again. So it's all the stuff to the left of 2, all the stuff to the right of 2, just not 2. And so since it can't equal 2, we're not going to put brackets. We're going to put parentheses, right? So parenthesis here, parenthesis here. So it's everything but 2. How we write that in interval notation? Well, this is going to negative infinity. This is going to positive infinity. And so it's going to be from negative infinity to 2. Don't include 2. You can't include infinity. Union, I have to write it down here, 2 to positive infinity. And so that's how it's going to be written in interval notation. So these are all the different ways they can be written. Just depends what you're being asked for on the homework or whatnot. Okay. Let's look at another example. Let's say we want to know the domain of 5x minus x squared. This is number 2. So, same process. We're going to assume it can be whatever it wants, negative infinity to positive infinity. And so that's going to be the assumption we make. The second step, is there an x in the denominator? Is there an x below a fraction bar? There is no fraction bar here, so we don't have to worry about that. No limitations there. Next thing, is there an x under an even root? Nope, not in this case. There's no roots there, and so our domain is going to be negative infinity to positive infinity. You can also write that as all reals or all real numbers, however you want to write it. Okay, and lastly, let's look at one more. Number 3. We have the square root of 3 minus 2x. Now here, we're going to do the same thing. We're going to assume they can be negative infinity, positive infinity. Is there an x in a denominator? No, so no limitations there. Nothing I need to take out. Is there an x under even root? oh, I got an even root here. This is an understood 2 on that root. There's definitely an x there. So I do need to worry about that. And so what I need to do is make sure that that stuff underneath the root, the expression underneath the root, which in this case is 3 minus 2x, that needs to be greater than or equal to 0. The reason being is we cannot take an even root of a negative number. So that stuff under there needs to be greater than or equal to 0. If you do take an even root of a negative number, just as a one-off, that is an imaginary number, which we're not dealing with in this course. So let's solve this up. I know we haven't learned how to do these, and we're not going to do anything complicated right now, but we just need to get the x by itself. So we'll subtract 3 from both sides. And then we'll have negative 2x is greater than or equal to negative 3. And we'll divide by negative 2, which is going to switch the inequality. And so we'll have x is less than or equal to 3/2. And so this is one way to write it. We could write it in the set builder notation that we were talking about earlier, be x such that x is less than or equal to 3/2. Or we can write it in interval notation. Let's get a number line going. Let's say 0, 1, 2, 3, 4, and negative 1, negative 2, negative 3. That's fine. And where's 1/2? Well, I mean 3/2. Where's 3/2? Well, 3/2 is basically the same thing as 1 and 1/2, right? And so 3/2 is going to be about here between the 1 and the 2. So, oh, not there, here. And so we know that it is less than or equal to that. So that means it's going to have a bracket there, and then it's everything to the left of that. Let's just use a paintbrush. And so if we write that in interval notation, it's going to be, this is going towards negative infinity, it'll be negative infinity, 3/2. And that would be our two ways of writing the answer there. Or if it allows you to write it as inequality, that one there. All right, and that's it for finding the domain of a variable.